All right, so how do we figure out which intermolecular force is acting between or among these molecules, okay? So we have methane, our first example, right? To figure out what intermolecular force is acting among many methane molecules, what you need to do is to take a look at what's happening inside. Which kind of bond do you have? So when you get electronegativities, okay, you have 2.55, okay, for the electronegativity for carbon minus 2.20, which is that for hydrogen. Okay, remember you're just taking a look at one of the bonds that are occurring. Okay, so for example, if we have carbon, okay, and then the hydrogens around, okay, you're just looking at one of these bonds, one of these four, only one. Okay, so here you have the difference being this, and remember this comes in the range, okay, for non-polar covalent bonds. So the type of bond occurring within this molecule is non-polar covalent. So what's happening on the outside then? You're only having London dispersion forces acting, okay? So then you check the next molecule, all right? And you see you have CH again. We check the strength between the carbon and the hydrogen, all right? And then you have OH, okay? Remember this OH was which kind of bond? All right, here you have a very strong, okay, bond, which is the hydrogen bond. All right, and then on this section of the molecule, you will see that you have London dispersion forces acting. So the forces present in this molecule, all right, are London dispersion forces, okay, for this section, which you just checked on the top, okay, carbon and hydrogen, carbon, hydrogen, it's a nonpolar covalent, so you have London dispersion force, and then you have hydrogen bonding, okay, because it's OH. Remember, for hydrogen bonding, it's FH, NH, or OH, okay? All right, our final molecule, okay? We have, once again, the C and H. What kind of bond we said it was? We said it was a non-polar covalent. All right, so what kind of force are these going to exert to the next molecule? All right, this whole thing is going to be London dispersion force, okay? But here we have something interesting. We have carbon and oxygen, and we need to check for that. So we check carbon and we check oxygen. All right, carbon 2.55. How do you know this number? Remember to look at the electronegativity table. Okay, and then we have 3.44 for oxygen. How do we figure out the difference? Just take the big one, subtract the small one. Okay, what do you have as result? Right? You have 0.89. So this falls in the range of polar covalent, okay? So that means that this has some polarization, that this is partially negative, that this is partially positive, okay? And that the bond that is going to occur there, okay, it's going to be, in this part of your molecule, a dipole-dipole bond, okay? Or intermolecular force. You check the next section, C and H again. What was this? C and H, it was London dispersion force because you had the nonpolar covalent. And then finally, okay, you check, make sure everybody has their valence complete. All right. And you have an OH all the way to the end. Okay, and we said that if you encounter an OH, O first, H last, okay, then this is going to be hydrogen bond. Okay, so the three types of forces are acting, okay, between this molecule and the next molecule and the next and the next, all the ones around, if they are made of the same components. Okay.